Welcome all my dears, welcome everyone. Welcome all my dears. We are going for a new part today to talk about a new part on the division and the functions, the division of functions. So we will work on a part today. Is very important and for you guys to understand it. Let's go, for example, directly, and I will just go for I did this example before without using the board, but I will do it right now with using the board so that it will be clear for everyone. Let's go for it right now. Let's go for it right now and see how we can do it using the board. How we can do this using the board. The division is like this. This is unit 2, division of polynomial functions. And we will go right ahead into this example, which is in front of you here, which said to me, divide this, express the results in quotient form. The quotient form is the long form which you studied before. Divided in the quotient form. Here is the quotient form, this word. Like I said before, the quotient is the one which we studied in elementary schools or in preparatory school, in the middle school. This is very easy way, but you have to be very careful because of the powers. So here, if I say that this is the example, x cubic, I will just write the example first, plus 3x squared plus 3x squared. Let's go like this. X cubic plus 3x squared minus 2x plus 5 minus 2x plus 5. And that is divided by x plus 1. X plus 1. Here it is. So what I will do firstly, I will just now stop the sharing the screen so that you can see it on the board here. Here is the example in front of me. And I will go now one by one. The first thing is that I will divide the powers. The largest power which I have is x squared here. X squared divided by x. I will divide x squared by x. That will give me x2. X power 2. X power 2, like you see here, x power 2. Then I will multiply x power 2 by those two factors. So x power 2 multiplied by x, that will give me x power 3 plus, I have here, plus the x power 2 multiplied by 1, that will give me x power 2. Then I draw a line. That will be minus, and that one also will be minus. So this will go with this because x power square, the minus x power, x power 3 minus x power 3, that will go with each other. So still with me here, 3x squared minus 1x squared, that will give me 2x squared. Then I will put the other numbers, which is minus 2x and plus 5. Cool, guys? Very cool. Now I will divide this number, which is 2x squared divided by x here. I will divide 2x squared divided by x. So here, to divide 2x squared by x, here I will just 2x squared divided by x. When I do 2x squared divided by x, when we divide, we subtract the power. So it will be equal 2x. So it will equal 2x. It's here plus 2x. Now, it's my turn back to take the 2x and multiply by this amount. So 2x multiplied by x will give me 2x squared. 2x multiplied by this x, 2x multiplied by this x will give me 2x squared. Then 2x plus 1, that is plus 1. Okay, guys? 2x plus 1. 1 what? 2x plus 1, x. Which is 2x plus x. Okay. Here I will just go right now and see. Just a sec. Here it will be 2x squared, and this 2x plus 1 will be 2x. Here it is, because this is 2x multiplied by 1 will give me 2x. Okay, then here, the 2x squared, this one, with x, the 2x squared, and 2x plus 1, this will be 2x. Then this will be negative, and this one will be positive as it is, so it will be negative. Then this will go with this, and this will be minus 4x plus 5. Minus 4x plus 5. Now, I will take the minus 4x and I will divide it by x. That will give me here minus 4. Minus 4x divided by x will give me minus 4. Now, I will take back the minus 4 and multiply it by the two numbers. And multiply it by the two numbers. Minus 4 in x, that will give me minus 4x. And minus 4 multiplied by 1 will give me minus 4. So here now, I will subtract. This will be positive. This will be positive. This will go with this. And 5 and 4 are 9. So here, this is the remainder or the remain. 9 is remained from this division. And for that reason, when I write it, I will write it like this. I will write it by this way. You guys get it now? So 9 is remaining here from this finishing. I will just do what? Like I showed you here. 9 is remained. Here in the whole procedures. And 9 will remain from the whole division. Then I can write it on this figure. I can write it on this figure. I can write it now. The end will equal the end solution will equal the output of the division, which is x squared plus 2x minus 4. Okay, then what's happened here is 9. Then this all on a brackets like this, plus 9, which is a remainder, divided by x plus 1, which is what I divide on. Because it looks like this. This is output plus the 9 divided by the x plus 1. That is a way to do it. The second way to do this is using the factor theorem. We call it the factor theorem. And I will show you right now what do we mean by the factor theorem. Here is the same example which I did. Let me just go to share the screen back. Okay, guys, let us share the screen back. And I did this before, the same example, I did it before in one of the, here it is. Like I showed you on the board, the same results and the same numbers which we get. At the end, we divide the output, which is x squared plus 2x minus 4. And we divided that's the final results, x squared plus 2x minus 4, plus what remain here? The remain is 9. Divided by what I divide the whole amount on, which is x plus 1. Okay, we call this quotient form. Like you see here, we call it the quotient form. But if there is another way to do the factor theory, yes, we have another way. We have another way, we call it the theorem, remainder theorem or factor theorem. Let us see what we will do. The same example? Yes, the same example. I will do it with the factor theorem. How I will do this, it's very easy. And this is the second way. So the first way, remember, the name is quotient. The name is quotient for the first way. The second way we'll do it right now is not the synthetic. I will come to the synthetic later on right now. But we will do it dividing on factor theorem. Okay, the factor theorem is telling me if it is the end is 0, this is a factor. If the end of the operation is 0, then this is a factor. This is a factor. We call it the factor theorem. This is the factor. If it doesn't equal 0, then not a factor. So the 9 which we get the remainder from the previous example, We will check now the same example, the same exercise, and see we will get the 9 when we use this factor theorem or no. If we get this number, then it's we'll apply this rule. So if we have 0, this is let me just stop sharing so that you guys can see. So if it is 0, then this is a factor. So if it is 0, like I said, just let me write it. If the outputs of the factor theorem, this is the factor, F-A-C-T-O-R, theory or theorem. Factor theory is telling me if the output, the end of the example is 0, then it is a factor. If it is not 0, then it is not a factor. That's it. So we'll see now the remainder. Can we get it with the same way we did for the first example, which we did right now? Let us go back to the first example, which we did right now, and write it back. That's the one which we did, right? X cubic. We'll do it now with the factor theorem. Use factor theorem or theory to get the remainder. Factor theory to get the remainder. Here, the example is x cubic plus 3x squared. The same example which we did before, minus 2x and plus 5. So we'll apply this right now for the x plus 1. That is what we divide on. We divide on x plus 1. So now I will say x plus 1 equal 0. Then I will move the 1 to the other side. X will equal minus 1. I will move the 1 the other side. It will be x minus 1. Then I will say now substitute in the main formula. Then I will substitute in the main formula. The main formula which I have is this one. So I would say now f(x), which is f minus 1, will equal this number x cubic will be minus 1 cubic plus 3 multiplied by minus 1 squared minus 2 multiplied by minus 1 plus 5. Then this will be minus 1 squared means minus 1 multiplied by minus 1 multiplied by minus 1, which means minus 1. This minus 1 all square is 1. Multiplied by 3, that will be 3. Then minus 2 and minus 1, minus 2 and minus 1, that will give me 2. Minus and minus positive, like we said before. Then plus 5. Then I will say now 3 plus 2 plus 5, 3 plus 2 plus 5, that will equal 10. 10 minus 1, that will give me 9. It's the same remainder or the same remain which was in the previous example, which is the same example we did it with the division, and it gave me this number, the same number. So in that case, it gave me the same output, same, the remainder was 9. So now, since this 9 is not 0, 9 is not factor. So means that 9 is not factor because it is greater than 0. Because as 9 is greater than 0. 9 is greater than 0. But if it was a 0, then no remainder, no remain, then in that case, it will be a factor in that. The same example, we did it once with the division, and the other ones we did it with the remainder. And you can see also that this, the factor theory, or the factor theory, which you can see in front of you here, this factor theory, don't forget the name, factor theory, is very easy way to get the results, the factor theory, because you don't need to make division. You will know only the factor. Because if you don't get the outcome, you will only get the remainder of the whole operation. But you don't get it like the other one. Like as example here, let me show you. We'll go back and share the screen. So here, if we go back, look at this, we get the remainder was 9. The same example, the remainder was 9, which we did in the board right now. The same example, the remainder is 9. But in the same time, you didn't get the output here. But in the quotient form, you will get the output of the division. This is the only difference. But to know if there is a remainder or no, that's what we, you can use this way, the factor theorem, to know if there is a remainder or no. Here it is. Determine is a factor of each polynomial. So here, the first example we did it, it was 9, then it's not a factor. As long as it doesn't equal 0, it's not a factor. Look at this here. So here are the 3 examples he did for the factor using factor theorem. Just substitute with the value which you have. Then you have here, this is not a factor because it's -9. 0 is a factor. And here 0 is a factor as well. So 0 is factors, but any number, an integer, is not a factor. And that is the second part which we have today in this course, in this lecture. Okay, guys. The third part we will do is the synthetic way of division. So we have 3 ways now to do about the remainder of any function. The third way is the synthetic division. Synthetic division. Synthetic division is a very nice way to get the results. And I will show you this example right now. And just let me enlarge it a little bit so that it can be clear more. And I can see it as well. Okay. Okay, this is example for the synthetic way. Here is the quotient way. So the quotient is like a long division like what you see here. We'll go now to the synthetic. I just want to see an example here. Here it is. Let me take this example. And do it for you with the synthetic way. And see what will remain for us. So here we have x squared minus 7x minus 6. There's one better than this one, I think. There was a one better than this one. It's inclusive, all inclusive. It was a better one than this one. However, we will work on this one, no problem, it's okay. We'll take this one, 2x squared, 2x cubic. It's all inclusive. I'm looking for an example which is all inclusive, like 2x cubic, 2x cubic minus 7x squared minus 7x squared. This is cubic. Minus 7x squared minus 7x minus 7x and plus 19 plus 19, and the division on by x minus 1. And I will just do the board for you guys right now. I will stop sharing the screen so I can see the board So we can do this. This we will do it by the synthetic way right now. We'll do it by the synthetic way. Okay, cool. That's very nice. So here, I will substitute with the values. Since it is -1, I will do like this, the solution. I will do for the solution like this. We go here. Check out the screen is showing up to you or no. That's nice. Screen is showing up to you. That's fine. Then I said x -1, right? Then I will put here 1. Because x -1, I will put with a different signal. So this will be 1. Now, I will put the coefficients of all the powers. But I want you to notice one thing. Here I go from power 3, power 2, power 1, and this is the constant, which is power 0. So I will do the powers. I will put the powers. I will put the leading coefficient. Okay, guys? But I will go in gradually descending for the power. Okay, if there was no here zeros, if there was no x squared, I put 0. So I go based on the squares. As example, if 3, I will put for 3. There is no square, then I will replace it with 0 here. I will replace it with 0 and so on. So the point is that you respect what's not there. You write 0. If you find something is not there, you write 0. Now I will go here for these factors. I will say 2 minus, here is -7, because this is -7, and this is also -7, and this is 19 plus 19. Usually put it with its own signal so that you will not confuse or not miss anything. Now, let us go like this. We will go in a very, very easy way. You will get it very quickly. I will put down this 2 first. I will put down this 2 first. Then I will multiply 1 times 2. That will give me how much, guys? 2. 1 times 2. This is multiplied by this. And I will put it here. On the second, not here. I will put it here. Okay. Now, what I will do here is -7 plus 2. I don't put minus here. Just directly. This is equals. -7 plus 2 will equal -5. Right? I will put -5 here. -5 here. Now, same things which I did when I multiplied 2 by 1 and gave me 2. And now I will multiply the 2 here, the 1 by -5, the 1 by -5. So it gives me -5. I will put the -5 here. Okay, 1 -5. Every time I go like this. From this factor here, I multiply it by the outcomes which I got here and put the number here. So here now, -7 plus -5, that will equal -12. -12. Cool, guys. Then I will take the -12 and put it here. -12, I will put it here. And this is the last thing. It's very easy. It's very, very easy because it takes from you 1 second to do it. Then this will equal 19 minus 7, 12. That will give me 7. So what is the meaning of this? What do we mean by this outcomes or out results? It's very easy now to understand it. This will be x squared, not x cubic. Okay, guys? Here, two x squared. When I get it 2x squared, then I have -5x. This is -5x. Then this will be -12. What about the 7? 7 is the remainder. 7 is the remainder. Then what I will do with the 7? Just write it down, like we see here. Okay. Plus 7. That is together. like this way, plus 7. Okay, that is another example on how we do the remainder. So that's another example of how we do the remainder. This is the outcome. So you get the synthetic here, you get the results only by just a very easy step, like I showed you before, a very easy step, like you do here. 2x squared, you will put the 2. Minus 7x squared, 2x cubic, you put the 2. Minus 7x squared, you will put the minus 7. Minus 7. Notice if this was not here, if a square was not here, you will put here 0. If there was nothing here, you will put here, replace it, because we go gradually descending based on the power, not based on the coefficient, based on the power of the x. Then here now, I'll put the 2 down, then multiply 1 by 2, that will give me 2. I would say minus 7 plus 2 will give me minus 5. Again, I will multiply 1 by minus 5, will give me minus 5. Then minus 7 plus minus 5, that will give me minus 12. You don't subtract. You add them together with their own signal. Don't change the signals. Do not change the signals. The positive, positive, the negative, negative. You don't change. Then here, minus and minus, that's minus 12. Then I would say again, 1 multiplied by minus 12 will give me minus 12. Then this is the last number, 19 minus 12. That will give me 7. 7 will be the remainder, or the remainder of this. We call it this synthetic method. So we call this synthetic method. And the synthetic method is just for doing the division, like I said before. And I did this before, actually, in front of you on the monitor, basically before. This is the synthetic method. And we'd like to see here, we divided and put the remainder alone. So we'll put the single alone and we'll put the remainder alone, like that way. Okay, guys, the remainder will be 7. Of course, I divided on x minus 1. In the start itself, I divided on x minus 1. Okay, guys, so this is how it looks like, at the end of the exercise. You have also here some other examples. You can do them. It seems we have now did 3 things in this lecture. Let me remind you quickly, we did 3 things in this lecture. First of all, we did the division using the long way, or we call it the quotient form. And the quotient form, we did it by that way, based on the quotient form. So here it is. The second way we did it was based on the synthetic, which I said synthetic is very easy way to do it. And like you see here, we get the results. It's very easy to get our results. Here, the same example which I did. Then the third way, which said is the factor theorem, and the factor theorem is just the easiest way of them, because you substitute with what you have in the formula. So as example, our example was x equal minus 1, and we substituted the formula. Then we get here. So as long as it's not 0, then it's not a factor. Here, minus 9 is not a factor. 0 is a factor, and 0 is a factor, and that's it. And by the way, the minus 9 here is a reminder as well. Thank you so much. Go to the next part.